This presentation is on the Arab mathematician Al-Khwarizmi, his work and his contribution to the field of mathematics, particularly to algebra and equation solving. So to begin, let's briefly review some of the individuals and civilizations before Al-Khwarizmi that could solve equations. So the Babylonians were the first recorded to have solved linear and quadratic equations. This was as early as the 1800s BC, and the Egyptians weren't far behind. There's a Rhind papyrus that's an ancient collection of problems that the Egyptians solved that included linear and quadratic equations with solutions. One example is shown here, the x squared plus x equals 3/4. So as you can see, they were solving pretty complex equations even back then. And other civilizations that could also solve equations really early were the Chinese and the Indian mathematicians. So as far as individual mathematicians, one of the largest contributors to algebra was the Greek mathematician Diophantus. This is a mathematician who actually shares the distinction with Khwarizmi of the father of algebra. We don't know much about him. He probably lived in the 3rd century AD, but we do know that he solved pretty complex equations. For instance, he's recorded to have solved systems of quadratic equations, but in his solutions, he always discarded the negative number solutions because back then those weren't considered meaningful, though he wasn't afraid to find rational non-integer solutions. One famous type of equation that he studied was the equation where you're only supposed to find integer solutions, what we call Diophantan equations. Fermat's last theorem, which I have on the right there, is an example of a problem involving Diophantan equations. And this was just proven by Andrew Wiles just recently, within the past couple decades. So as you can see, the problems of Diophantus really outlasted him by several centuries. Now we'll talk about the subject of this presentation, Al-Khwarizmi. He was born late 8th century, around what's now known as Baghdad, Iraq. A couple decades after he was born, there was a struggle for power between the sons of the recently deceased ruler of Baghdad. And after the struggle, the victorious son established, among other things, an academy called the House of Wisdom. And Khwarizmi eventually became one of the first students at the House of Wisdom. Back in the 5th century, when the Greek Empire fell, the Arabs gained possession of all these Greek scientific texts. And so at the House of Wisdom, that's what the students translated and studied. So at the House of Wisdom, Al-Khwarizmi studied algebra, geometry, and astronomy, and he wrote on his discoveries in these areas. One of his most famous works is his algebra work, and the title is shown here, which translates roughly to the compendious book on calculation by completion and balancing. The ultimate purpose of this book is to aid in solving the practical problems of the day, things like land division, marketplace, dealings, and for example, the last section of his book talks about the intricate rules of Islamic inheritance. Interestingly, the treatise uses really only words to describe the problems, so there are no symbols and there aren't even numbers to describe the problems. So it's really not a book about algebra for algebra's sake. However, Khwarizmi does carefully build up to the algebra that he discusses in his book. For instance, in one section he talks about how to generate the set of natural numbers by starting with 1, then adding 1 to 1 to get 2, and adding another 1 to get 3, and so on. But for the most part, most of the math of in his book is really just more of a set of problems and solutions, as opposed to a collection of generalized solutions and algorithms for finding solutions. In the title of his book, Al-Khwarizmi mentions two of the methods that he uses in his book, which are completion and balancing. So completion is really more about making sure you don't subtract any terms, because again, it's the negative values weren't really considered meaningful. So for instance, for the equation shown, instead of subtracting 5 from the right-hand side, you add it to the left-hand side. And for balancing, it's really more about making sure that each term or each type of term only shows up once in the equation. So for instance, for the equation here, x squared plus 2x equals 6, you have the x squareds and the x's on the left-hand side and the constants on the right-hand side. So because Khwarizmi uses the completion method in his book, he separates different types of quadratic and linear equations into different classes based on where the squares, roots, and numbers fall on which side of the equation. And squares, roots, and numbers are just the x squared, x, and constant terms, respectively. And here's a list of how he classifies the equations. Also in his book, Khwarizmi includes some proofs to some of his problems, so geometric proofs that are of the form of completing the square. So for instance, in the problem we have here, x squared plus 10x equals 39, Khwarizmi starts with a square of area, x squared, and then adds 4 rectangles whose sum is equal in area to the roots term, the 10x term, and then he adds 4 corner squares, which are just numbers, to complete the square. And equivalently for the equation, he adds these numbers to both sides. So then the equation reduces to x plus 5 squared equals 8 squared. And since we're only dealing with positive numbers, this really just reduces to a linear equation of x plus 5 equals 8. One reason why Al-Khwarizmi has the nickname the father of algebra is because of his impact on European mathematics. So in another one of his books, he advocated for the use of Hindu numerals, which is where we get our Arabic numerals that most civilizations use today. And he was also the first to use the symbol that we use for 0. The Arabic name for the symbol that he used is actually where we get our word cipher, C-I-P-H-E-R. And his ideas really started to really spread when mathematicians like Fibonacci and others got hold of his works and translated them into Latin, and after that they spread rapidly, and so much so that the Hindu/Arabic numerals that he advocated, Khwarizmi advocated, supplanted the Roman numerals that were being used all over Europe at that time. So we actually have quite a bit of evidence showing just how influential Al-Khwarizmi was, even within the past century. First of all, the stamp that you see in the top right corner was issued in the 1980s in the USSR to celebrate 1,200 years of Khwarizmi's, achievements and impact. And also we get a couple words in our English language from the Latinization of Khwarizmi's name, So one word that we get is algorithm, which mathematicians and computer scientists use a lot. And we also have the word algorithm, which is another word for the system of Arabic numerals, which is very fitting. And actually, the English language isn't the only language. Spanish and Portuguese also use the Latinization of his name for their words for digit. So Al-Khwarizmi made quite an impact on algebra worldwide and a lasting impact on the field of mathematics as a whole. Thank you for listening to my presentation.